Okay, so today we're going to talk about function, when it can be a function, when it cannot be a function. Um, First of all, function is a relation. Now, what is a relation? It's just a fancy way of saying you have a pair x and y. So any graph that you can put x and y on it, then it's a relation. Right? It's pretty simple. Don't write this down. So here's a relation. Here I have a bunch of input, my x value, and over here I have my y value. It doesn't matter how many, as long as you can project x to y like that, or you can project the last one to the first one. It doesn't matter, as long as you can write it as the order x y, then it's a relation, right? It's pretty easy going. Now the function is a little bit more pickier. It's a relation, that means it has an order x y. However, each element in X assigned to exactly one element in Y. So the function is a relation that assigned to each element in the domain in the X values, exactly one element in the range. What does that mean? Well, I'm not going to test you on how to memorize the definition, but what you need to know from this is that X values cannot be repeated. That's the informal way to remember it. Yes.
Sorry, the title
Oh, the title is Functions and Their Graphs. Mm-hmm. Oh, they're right there. Title in yellow part. So let's go to my notes so I can see the extra credit. X value is the input value. It is independent. You can choose X value can be anything, right? Independent variable. However, Y value, well, they call that the output. That's your f of x. It's the dependent variable. Dependent variable depend on x. Whatever x is, whatever you put x into the function, y is going to be it. And I call this, if I have f of x equal y, if I have y, which is sometimes I write it like f of x, or I just write f, then we call this y is a function. Let me. Y is a function of x. If you want to replace the letter x with t, y is a function of t, y is a function of a, whatever. Is it a function? 1a? Is it a function? Yes, thank you. Yes, right. There's no x repeated. So 1, 2, 3, no x repeated. So yes. One B. No, right? One x value take to two y value. So no x repeated. Is there any question? It's a good time to ask. Can you see it? Yeah, can you see it? Okay. Let me ask you this question. Don't write this down, just something like X plus Y. Here's names. Say Penny, Yam, Jeff, and here the birthday. Just make things up, okay? Make things up. Is it a function? Yes, right. There's no every X is one Y, right? They all have different birthdays, so it is a function. Evaluating functions. So now we understand what is a function. Now we're gonna evaluate with certain values. Here's a function f of x equal x squared plus 2x. I want to evaluate at x equals 0. So if I was you, I'll write like this. So every time I see an x, I replace with a parenthesis. And then I plug it in my value I want to replace, which is 0. I want to evaluate -3, not 3. Let me modify this a little bit. So f of -3. Why don't you do that? It's okay, that's all right. I do give you guys partial credit, right? Even though I answered wrong, I still give you partial credit. 15, -15. What else? Yeah. Oh, sorry. I modified it. Oh, sorry. Yeah. Then do it again. What else? Well, I have 15, -15, 3, 3. All right. I'll tell you. That's okay. I'm glad you made mistake, and I'll tell you why some people make mistake, which is good. Which is good. What's -3 squared? Yeah, -3 squared is the same thing as -3 times -3, which is +9, right? And then 2 times -3, that's -6, so 3. Now be careful. If I have something like this, let me tell you the difference between the -3 inside the parenthesis and then you square and the one that you don't get the parenthesis, which is usually, I think you got the wrong answer because you put this in your calculator. This means what? Is the negative belong to 3 and it belong to the square? No, this is the same thing as -1 times 3 squared, right? So without the parenthesis, the negative is actually not going to be square. So here you only square the 3, so negative 1 times 9, which is negative 9. So be careful, the parentheses make a huge difference. F of A, same thing, right? So instead of f of x, it's going to be a squared plus 2a. Anybody have f of negative x yet? Oh, no. Are you talking about D? Negative x. Anyone else? X minus 2x. What's your name? Okay. Anything else? I'm glad we have different answers so that I can, I know what you get wrong, so I try to fix you now. All right, let's plug it in. What's negative x parentheses square? X squared, right? Because negative x parentheses square is a negative x times negative x, right? Which is, oops, negative, which is positive x squared. So x squared, and then 2 times negative x is negative 2x. My advice to you, when I'm asking you to do something like this, which I will, replace the variable with the parenthesis, and then you plug it in later. So you don't make silly mistake, like a negative, especially when it comes to negative. Is any question on number 1? Number 2 is called a piecewise function. The reason it's called piecewise because you see how many pieces here? 2 pieces, right? It could be. Piecewise function composed of many little functions. And the domain will be the union of each of those little functions. Hence pieces. I want to compute f of 0. Unlike regular function, I only have 1 to pick from. I got 2's here. Which one should I pick for my f of 0? Yes, why? Yeah, but 0 belongs to that range, right? Belongs to that domain. So we're going to pick the top one. So the top one is negative something plus 1. And that something now is 0. 1. Negative 0 is the same thing as 0. And then f of 2. The bottom one says square root of something, subtract 1. Square root of 1, which is 1. Scrap work. Scrap work's not important. You probably have something like that on LinkedIn. Very easy. Let's talk about the domain and range of the function. Now, if I give you a graph, it's easy to eyeball the graph, right? And then tell me the domain and range. So say here, for example, if I have y equal, what is my domain? It's kind of lacking. What is my domain? What is the domain, by the way? All the x values, right? So you want to look at the x-axis. Yes, everything, right? Everything. If you look at it, if I can take a value on the x-axis and then project it up to the red graph, I always get a y value, right? I always touch the graph. So, and of course, it extends to infinity both ends. So all real number. Or you want to write interval notation, negative infinity to positive infinity. What about the range? Range is your y value. Where does it start? Zero, right? It starts 0 and then go up to. So domain of a function is all the x value, the set of all real x value for which y is defined. Let me write something more. X value go from smallest to largest. You always start from left to right. The range instead of all y value corresponds to some x in the domain, meaning just the vertical perspective of it. I need to highlight in red actually. So the y values still go from smallest to largest. And this time, bottom top, bottom to top. Now, what if I don't give you the picture? What if you had to tell me the domain without graphing the picture? Well, there are certain rules that you want to know, and you see this again and again if you take more math classes. I want you to find the domain of y equal 5x squared plus 4. What kind of function is that? Quadratic, right? Quadratic. Now quadratic is one of the functions belong to a family called polynomial function. Remember polynomial function? Say x, y for x is a polynomial function with degree is 1, x to the first. X squared, degree 2, x cubed, x4, x5, etc. Those are polynomial functions. All the polynomial function has the domain from negative infinity to positive infinity. You know what? Let's talk about the domain first. Let's talk about the domain first. Don't have to talk about range. Just talk about domain first. Negative infinity to positive infinity. Do I want to talk about the range? Just domain first. Because the range, you have to look at the picture. All right. Let me put a little side note here. Maybe dark green. Remark. All polynomial functions we can call it R. And let me remind you what is a polynomial function. Let me remind you, polynomial function is look like this. x to the first, which I don't write. What's x to the 0? Which I don't write there, right? A naught. I could have write a naught x to the 0, but x to the 0 is 1, so I just write a naught, which is your constant, right? If you start out like degree 5. By the way, these a here, they all coefficient, which is not important. What important I want you to focus on is the degree of x. If I start at x to the 5th, so n is 5 here, and then x to the 5 minus 1, x to the 4, x to 2, x squared, and all that. What about number 2? What is the domain of the number 2? What kind of function I have now? Yeah, for rational, right? Rational. Well, I don't think you need like to know any rule about rational function. Intuitively, what can you tell me from what you know about fraction? What can't be there? Yeah. Well, what can be there is if the denominator is 0, right? So any value as long as my denominator is not 0, I'm okay. Can the top be 0? Yeah, it's fine, right? 0 divided by number is 0, but there's no number divided by 0 is give me anything. So here is the rational function, and all you do is set the denominator equals to 0. So for x, x equals 6, x equals 2. You say x cannot be equal to 2. Can someone give me the interval notation? If you're stuck, draw it out. That's 2. Anything but 2. So I see 2 intervals, right? I take everything from negative infinity up to 2, bracket or parenthesis around 2. Bracket or parenthesis? No, I see somebody shake their head, so it's gonna be parenthesis. What does parenthesis mean? Huh? Yeah, 2 is not included. You get up to 2, like 1.9999, very close to it, but never quite at it, right? Union start from 2.00001, right, up to infinity. Remark. Domain of rational function. Well, you want to say fraction, that's fine. Rational function is where the denominator equals to 0. Let's take a look at this graph. I'm curious, what happened at 2? But I want to see what happened at 2. Y equal. Can somebody tell me what the numerator equals something? That's fine. What happened at 2? Hmm? Look at the function at 2. It's going from the left of 2, it's kind of come down to the negative infinity, right? And then from the right of 2, it's shoot up to positive infinity. Right, so the function is go crazy there. Yes. Yes, a vertical asymptote. Mm-hmm. Vertical asymptote is more severe than horizontal asymptote. You can ever cross that. Think of a black hole. We don't know what happened there. It just one function is just kind of degrading, just falling apart. Number 3 is a radical function. There are 2 types of radical function. One type I have the odd root, like cube root, fifth root, seventh root, etc. Right, odd root. These number here I call them index, and whatever under the radical is a radicand. This terminology here, radicand, and the one I highlight in black, those are index. Your index is 3, and the root right there they call radical. For cube root. Oh, by the way, can I rewrite this problem like this? If it's the same as cube root, right? Yes, right. When I took my math class in undergrad, one of the professors say he see this as a boot method. So you draw a little cute little boot there, and you kick that 3 over. Let's see the first degree, and you kick that 3 over. 3 gonna stay in the bottom, and then the power of the radicand, just 1 in this case, stay on the top. It's called boot method. I thought it's kind of cute. Let's take a look at the function, the cube root function. I'm lazy, so I'm gonna raise to the 1. If you want to do cube root of x minus 1, same thing. Can someone tell me what the domain of my cube root function? Everything, right? If I were to change it into fifth root, same thing, right? There's 8 root. I'm sorry, 8, that's even. I'll say 9, same thing, right? You get a little bit, stretch a little bit taller, vertical stretch. So for odd root, your domain will be all number. They're easy going function. Where's your? I'm gonna take a look at your extra credit. Odd radical function as domain. Oh no, that's just the domain. I kind of crossed out the range. We're not talking about range here. Range, you need to take a look at the graph. You cannot tell the range by looking at the function. but domain you can. Now what about even root? If I forget about that complicated one. If I give you y equals square root of x, if I graph this, it looks like this. you notice that what is the domain of y equals square root of x? You start from 0, right? So that means wherever under the root has to be at least at 0. It has to be at least 0. It cannot be negative. That will be imaginary number, which we cannot see on the real graph. So for even roots, so even radican, so this one, domain, what you're going to do, you're going to set the radican greater or equal to 0. So that means 2x minus 1 at least 0. And then you solve. Add 1 both sides. Divide both sides by 2. So x is greater or equal to 1/2. If I write this in interval notation, because 1/2 is included, we're going to use bracket and it's greater than that. So all the way to infinity. Even radical function, let me write my radical. Set the radican greater or equal to 0 and solve. Yes. Mm-hmm. Yeah. Bracket means you include the 1/2, right? You take 1/2. 2 times 1/2 is 1. 1 minus 1 is 0. Square of 0 is 0. Let me ask you a question. What's the domain of number 5? You should know. Yes.
I have a quick question.
Uh-huh.
I don't know if you know, but the notes on Moodle are different from the notes you have here.
Oh, yes. I forgot to update that. I updated last night. Sorry about that. Sorry about that. I'll update it later. But thank you for letting me know. Yes. Yeah, I asked some more problems. Number five. What is the domain? Huh? Same thing. Plus. Well, same thing because it's even index, right? It's even root. The radican cannot be negative, so you set this greater or equal to 0. But because the whole thing is in the denominator now, there it was on the top, right? Here it was like this, right? But this one is in the denominator now. So what else you should do on top of that? What else? So the least you can do is you say 2x minus 1 is greater or equal to 0, yeah? Because it's a radical. What else? Can x be equal 1/2? Can I take it 1/2? Can I include 1/2? If I include 1/2, what I got? 0, right? And I cannot have that I cannot allow that. So if your radical is in the bottom, again even, then whatever it is, it has to be strictly positive. Right? So remove that equal sign. Strictly positive. You do like this. So the 2 together, that means 2x minus 1 is strictly positive. X is strictly greater than 1/2. if the radical is in the denominator, then set the radicand strictly greater than 0 and solve.
Professor, to clarify, if the radicand would have been in the numerator, then we still
it's the same
equal sign.
Yes, yes.
Okay.
I think your extra credit is coming up. I can't remember which one it is. Oh, sorry. It's okay. I'm gonna check, see which one I post on later. Today is the 20th. Like that. Like that. Let's do number 6 together. Number 7 is your extra credit. Number 6. Ooh, this one is, I have everything. So far, I show you what? I show you the polynomial. I show you rational. I show you radical, but they separately, right? What if I combine them all? What if I have radical, polynomial, and rational in one function? I call the combined function. Then you can take a look at each of them. Let's take a look at the top first. What restrictions should be on the top? First of all, it's the radical. It's the even radical. So what has to be under the radical? Well, the radicand has to be what? Can I include 0 on the top? Yes, right. So because this right here is the, sorry. So that's my first restriction. And then you solve. All right, are we done? Yes, it's greater or equal to 0. Am I done the top? The top okay, right? It has to be, it can be 0, it's fine. If it's 0 on the top, it's fine. And because it's even index, even radical, we said it's greater or equal to 0. What about the bottom? What kind of function in the denominator? It's a polynomial, right? Polynomial domain is all real number. However, it's in the bottom. So x minus 6 has to be, cannot be 0. And then you solve for x. I'm gonna grab this. I have a 3 here and a 6 here. I cannot take the 6. Cross that out. Cannot take the 6. I can take the 3 though. 3 is okay. You know, instead of cross it out, I'm gonna do hollow dot. Here is, I'm taking the 3, so I'm gonna do solid dot. Is that okay? Yeah. All right, look at that picture. Can someone come up with the interval notation? From left to right. Start where? Yeah. Don't try to do everything at once. Just one thing at a time. So start at negative infinity up to 3. Am I include 3? Oh, actually, can I start at negative infinity? Yeah, because I'm starting right here, right? It has to be greater than 3. Greater than 3. But then I skip the 6 and then move on from there. Yeah, yeah. So a bracket 3 could include 3 up to 6 union from 6 to infinity. So combined function is a little bit more complicated. As long as you remember what each function does, should be fine. Number 7, that's your extra credit. Maybe I'll let you have 2 attempts. Don't plug it in yet. I'm gonna fix this. So if you do, I cannot fix it. If you refresh your Moodle page, you should have 2 attempts. From now on, I'm gonna do 2 attempts. Oh, it's locked? Oh, I thought I fixed it. Why is it locked? I have January 20th. Oh, after. Okay. I see what I did wrong. Sorry. Restrict access from blah, 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 until refresh your Moodle should be good now. You can talk to each other. I don't mind. Share your answer to each other. That's the hardest part of today's section. From now on, will be very brief, easy. Application. I want to compute the height of the column below. What should be the restriction? So this is a function of the height of the column. This is the application problem. So the restriction is that the length has, because this is the height, so it's length, right? Length has to be what? Can length be negative? No, right? So it has to be greater or equal to 0. That's the restriction. So whatever the length is, in this case, the function 5x minus 10 has to be greater or equal to 0. And then you solve for x. Does anyone have a question for this problem?
What dictates the greater than or equal to again?
Oh, for this problem or
yeah, for this problem.
For this problem is because I'm talking about the height of a column.
Okay.
So height cannot be negative. So that's a restriction. More like a critical thinking kind of problem. All right, vertical line test. Let me tell you what does it do. VLT. Oh, so sorry. Maybe I'll show you a graph. The vertical line test, VLT, it used to check if the graph is from a function. Check a graph from a function. Or belong to a function. If it belongs to the function, it cannot. If it is a function, VLT only intersect the graph at most once. Make that black. It makes sense. Let me show you what happened. Let me show you. Is this a function? Yes, right? If you arbitrarily draw any VLT, arbitrarily draw, somebody can draw from here, it doesn't matter. Everywhere you draw, it's only intersect the graph at most one point, right? So yes, the black line is a function. If I give you something like this, is this a function? No, right? Because it cut the graph, the red one, two places here. And remember, if you are a function, x cannot be repeated, right? Here, if you take a look at the red graph, if I say I evaluate f of 3 there, 3 give me a positive value, and it also gives me a negative value. So it's repeated, right? That's why for the vertical line test, in your function, you're only allowed to intersect the graph once. That's your extra credit number 2. Here's A, here's B, here's C, here's D. That's easy enough. Oh, by the way, for A, don't worry about the dash line. I'm sorry. Please ignore it. Just pretend it's never there. Erase like that. It's never there. I cough when I chalk line. Last time to draw it back here. Like, you can see 4, 4, 4. I'll turn on the lights. Wiki. All right. Can you see? I want you to see the graph as well. On the exam, you have something like this. Not exactly, but very similar question. I give you the graph and I ask you a bunch of little questions. I want you to find f of 0. So when x is 0, what is the height of the function? 4. Huh? 4, right? 4. So easy enough, right? 4. You look at there. Find the values where find the values for x when f of x is 0. Now the reverse engineering. I give you the height. I want you to find the width, x. Yeah, -4 and 4, right? That's your x-intercept. So when the height is 0, no height. The function no height is let down -4, 4. You have a question? It looks like you have a question. Oh, okay. Oh, width. When I say width, I mean x value. Sorry. Yeah, it's how wide the graph goes. I want you to write like this: x equal curly bracket -4, 4. The reason I don't want you to write like this, because x equal 4, that's the whole line, right? That's a function. But when you put the bracket, it means element. Just coordinate. X-intercept. X-intercept. No, you can look at there. If the problem is 2 point, I'll give you 1 point. Can someone tell me why? It's correct answer. It just yes.
Is it a 4 negative 4?
Yeah, yes, you have just said the same thing she does.
So equal 0, right?
Yeah, so when I asked about x intercept, you're gonna give me a point. How many coordinates a point? Yeah.
Negative 4, 0.
Yeah. 0. In math, you're gonna answer precisely. The reason I'm making you do this because on the final exam, if they you keep -4, 4, if I give you 0. Okay. And by the way, somebody else grading your finals. I probably grade like 1 page. What is the y-intercept? The other way around. Yeah, that's okay. That's good. I want you to make a mistake now on the exam. You don't make the mistake anymore. Find the domain and write integral notation. What's the domain? You can look at the graph over there. Where does it start? Not negative infinity. Start at, yeah, bracket or parenthesis at -4. It might include -4. Yes, right. It's go through -4. So if you see something like that on the exam, I mean include, even though I don't put the little solid dot. And up to 4. What is the range? Where does it start? Yeah. It start from the x-axis, right? So it start from 0. Huh? Somebody said something. um, yeah. So where does it start? Yeah, 0. It start at the x-axis, so 0. Yeah, it's okay. I'm sorry. It's kind of light. And up to 4, right? Is 0 included? Right, 0 included. That's all you have to access. Can you do something like that on the exam? Yes. Oh, okay. All right. We're done for the day. Do you have any question? Feel free to leave. Have a wonderful weekend, and I'll see you again Monday.